Hello again, Algebra 2 students. Today we're going to do part 1 of section 8 and chapter 8. We are going to be solving radical equations. And we're going to start with what happens if we have an equation that just has a single radical in it. So we're looking at example number 1. And we have 3 onto the square root of x plus 6 plus 5 equals 14. And there are 2 steps. The first thing it says is to isolate the radical on one side of the equal sign. So that means that I'm going to want to get rid of the 3 that's being multiplied times the radical. I'm also going to want to get rid of the 5 that's being added to the radical. So if you can pretend for a moment, if that were just a problem like 3x plus 5 equals 14, what would you do first? Well, you would be subtracting the 5. So that's where we're going to start, subtracting 5 from each side. So now I have 3 onto the square root of x plus 6 equals 9. Now my goal is to get rid of the 3 that's being multiplied times the radical. So I'm going to do some division on each side. And that leaves me with the square root of x plus 6 equals 3. Sorry, this thing shakes so much. I'll hit the table every time I write and move it. All right, so now I want to do the second step because I finished the first step. I've isolated the radical. The second step says you raise both sides to the power of the index number on the radical. In other words, if I want to get rid of a square root, I need the opposite or inverse of a square root, which is to square both sides. Remember right here, if we don't see a number in the index, it's understood to be a 2. So whatever that number is, if it's a 2, if it's a 5, if it's an 11, whatever it is, that's the number that you're going to choose to raise both sides of your equation to. So I'm going to raise both sides to the second power. Now, why do we want to do that? Well, if I have a square root and I square it, it cancels each other out. So now I have x plus 6 equals 9 because 3 squared is 9. And then lastly, I have an easy problem now. And I'm going to move the 6 from each side with subtraction. And I am going to get that x is 3. Now you notice at the bottom there it says that you must check your solutions. So let me just remind you at the beginning of the chapter where we spent a lot of time talking about rational functions. Remember, a rational function is when you have a polynomial that's being divided by another polynomial. In other words, you have variables that could be in the top and in the bottom of your fraction. Well, remember, we always had to go back and take our solutions and plug them back in because we knew that if we plugged it in and it made the denominator 0, then it wasn't really a solution because we can't divide by 0. Well, because there were domain restrictions for that, that's why we had to do that. The same thing happens here. When you have a radical and your index is even, there are domain restrictions. And so that means that we have to plug it in to see if it works. So I'm going to go back to my original problem and I'm rewriting it. I'm going to put a question mark over the equal sign because that's what I'm trying to figure out. But now in place of the x, I'm going to plug in what we just got, which was a 3. And now we're going to do some math together. So 3 plus 6 is 9. The square root of 9 is 3. Then I would do multiplication. 3 times 3 is 9. And is 9 plus 5 14? Absolutely. So we would be able to say without a doubt that x equals 3 is a solution. What happens if you plug it in and it doesn't work out? Then we would say no solution. So that's definitely an option. All right, so let's take a look at example number 2. Remember, the first step is to isolate the radical. So I need to get rid of the plus 8. So I'm going to subtract 8 from each side. So I end up with the square root of 5x minus 1 equals negative 6. So we've successfully completed step 1. Now we want to look at what our index is. Again, I don't see a number. That means it's understood to be a 2. That's a square root. So the opposite of a square root is to square both sides. What that does is it takes my square root and my squared sign and it cancels each other out. On the other side, when I square a negative 6, I get a positive 36, which then we're going to add 1 to each side. So now I have 5x equals 37. Oops. And then I'm going to divide by 5. And I'm going to get that x is 37 over 5, which seems like a viable answer. But let's go back to the beginning, and we're going to plug it in just a moment to see if it works. So again, I'm going to take x out. I'm going to put 37/5 in its place. Well, if I multiply 5 times 37/5, the 5's cancel out, which leaves me with 37 minus 1. 37 minus 1 is 36, and that's a perfect square. So now I have 6 plus 8 equals 2. Is that true? No way, Jose, because that would be 14, and 14 definitely does not equal 2, which means that x cannot equal 37/5, which means my final answer to this problem is no solution. Nothing will work. Okay, so example number 3, same idea. Step 1, isolate the radical. So I'm going to subtract 2 from each side. So I have the cube root of 2x plus 1 equals 2. So if step 1 is done, now I notice that my index is a 3 because that's a cube root. So I'm going to raise each side to the 3rd power. I'm going to cube it. Well, a cube root and cubing something cancels each other out. So now we have 2x plus 1 equals 2 cubed, which is 8. Next, I'm going to subtract 1. Now I have 2x equals 7. And then I'm going to divide by 2. And I'm going to leave minus 7/2. If you want to change it to a decimal, that's fine. Remember, we have to go back and check it. So that's exactly what I'm getting ready to do. Again, I like to put the question mark over the equal sign because I'm showing that I want to check to make sure that works. And I'm going to plug in a 7/2. So 2 times 7 over 2, what's going to happen to those 2's? They're going to cancel out, which leaves us with 7 plus 1, which is 8. And 8 is a perfect cube. It turns into 2. Is 2 plus 2 4? It sure is. So our answer was indeed a solution. All right, example 4. Step 1's already done for us. The radical has been isolated. So I'm going to go ahead and square both sides because my index was a 2. Now, here's where I want to refresh your memory because this is a mistake that a lot of students make. So hear me out. Obviously, on the left-hand side, that's going to leave us with 2x minus 1 because the square root and the squared, they're going to cancel each other out. On the right-hand side, what does it mean if you have x minus 2 squared? It means that you have x minus 2 being multiplied by itself twice. So hopefully you recognize that you have to FOIL this out. You cannot just take that outside exponent of a 2 and distribute it into the parentheses. In fact, I have told y'all numerous times that the only time you are allowed to do that is if what's inside of the parentheses is multiplication or division. But we have a problem because we have subtraction. So you can't distribute the exponent. We're going to have to write it out and FOIL it out. So let's FOIL together. So first term, I would get x squared. Outer term, I'm going to get a negative 2x. Inner term, I'm also going to get a negative 2x. So I'm going to go ahead and combine those into a negative 4x. And then last, I'm going to get a positive 4. So I've FOILed it out. Now this problem's a little bit different, you might be noticing also, because now we have a quadratic because we have an x squared. And so remember, if you have something that's a quadratic, you have to get one side set equal to 0. So I'm going to subtract the 2x from each side. I'm also going to add the 1 to each side because I'm going to turn that left-hand side of the equal sign into a 0. So I'm moving everything over to the right. On the right side, I'm going to have x squared minus 6x plus 5. And if you do a sum and product chart, you can factor that into an x minus 1 and an x minus 5. So we're going to get two possible solutions. I'm going to find out that x could be 1 or x could be 5. But as you remember, we always have to go back and check. I'm going to start with the 1. So again, you're going back to the original problem. And everywhere that you see an x, you're going to plug in the 1. That's the one I've decided to start with. I'm plugging in a 1. So on the left-hand side, underneath the radical, 2 times 1 is 2. 2 minus 1 is 1. And the square root of 1 is 1. On the left-hand side, sorry, not left, that's a right. 1 minus 2 is -1. And those two things do not equal one another. So that cannot be a solution. Now I'm going to check our other possible solution. Again, you go back to the original, and everywhere you see an x, you're going to plug in a 5. All right, so underneath the radical, 2 times 5 is 10. 10 minus 1 is 9. The square root of 9 is 3. On the right side, 5 minus 2 is 3. Good news. Man, I'm hard on lead. Good news, x equals 5 is a solution. So again, it is super important that you go and you check your solutions. You might have an instance where both of them work, but in this case, only one of them did. All right, now let's see what happens when you have more than one radical. So far, we've only had a single radical in our problems, but sometimes you have more than one. And if that's the case, what it says is that to solve, each side of the equation should have one radical. So if they're both on the same side, we have to move one of them over. And then it says you may need to move one radical by adding or subtracting, which is exactly what we're going to do in example 1 here under section B. So I'm going to start by adding 2 onto the square root of x to both the left and the right hand side of the equal sign. So I have the square root of 3x plus 2 equals 2 onto the square root of x. So I moved one of those radicals over. I now have a single radical on both the left and the right hand side. Now the goal is to get rid of the radical. Well, we're going to do the same thing we've been doing. How do I get rid of a radical that has an index of 2? Easy. I'm going to raise both sides to the second power. So I'm squaring both sides. Let's talk about the left-hand side. The square root and the square, they're going to cancel each other out. So I have 3x plus 2. On the right-hand side, I want you to look inside of the parentheses. Those two things are joined together by multiplication, which means that I can take that outside exponent and it has to go to everything. So it doesn't just get to go to the square root of x. Yes, it's going to cancel that out and leave us with just an x, but it also has to go to the 2, and 2 squared turns into 4. And if you forget to do that, you're going to ruin the rest of the problem. So it has to go to everything that's on the inside, so the 2 squared turned into a 4, and the square root of x squared turned into just a plain x because the square root sign and the squared canceled each other out. Now I have a pretty easy problem, so I'm going to subtract 3x from each side, and I'm going to get that x is 2. But again, you have to go back and check it, and so we're going to go back to the original problem. So everywhere that I see an x, I am plugging in a 2. Man, me and lead, we are not friends because I break it all the time. I just write too hard. I think I need to go back to using 0.9 lead instead of 0.7. 0.7 breaks easily. All right, sorry, I just yammered on about all that. So under the first radical, 3 times 2 is 6. 6 plus 2 is 8. Now let's talk about the square root of 8, because it's not a perfect square, but 8 breaks down into 3 2's, which means that I have a group of 2's. So 2 gets to come out, 1 has to stay underneath. And what happens if you have 2 on the square root of 2 minus 2 on the square root of 2? Yep, it equals 0. So x equals 2 is definitely our solution. All right, next example. The good news is there's already a single radical on both sides, so we don't need to move anything. we can go straight into raising both sides to the third power. Again, I'm doing it to the third power because the index was a 3. It's going to cancel out the radical on each side, so I get x minus 5 equals 7 minus x. I think I'm going to move the x, so I'm going to add x to each side. So now I have 2x minus 5 equals 7. Going to add the 5 over to the other side. So now I have 2x equals 12. And then lastly, by dividing by 2, I'm getting that x equals 6. So let's go back and check it out. So I've got the cubed root of 6 minus 5, and we want to find out, does that equal the cubed root of 7 minus 6? All right, on the left side, 6 minus 5 is 1. The cube root of 1 is 1. On the right side, 7 minus 6 is 1, and the cube root of 1 is 1, and it works. So x equals 6 is the solution. Okay. Example 3 looks pretty straightforward, right? We have a single radical on each side. I'm going to raise both sides to the 4th power. So I've got 2x plus 1 equals x plus 6. I think I'm going to subtract the x from each side. So now I have x plus 1 equals 6. And then I'm going to subtract the 1. And I'm going to get that x is 5. Not too hard. Let's go check it out. So I have the 4th root of 2 times 5 plus 1. Does it equal the 4th root of 5 plus 6? Okay, on the left-hand side, 2 times 5 is 10. 10 plus 1 is 11. 11. Well, there's not a 4th root of 11 that's going to be a nice number, so I'm going to leave it that way. On the other side, 5 plus 6 is 11. So again, I get the 4th root of 11, and that would make sense. So x equals 5 is a solution that works. All right, 2 more examples, and then we're done, y'all. Okay, so next one, I have 2 radicals on one side. I'm going to move the one that has the minus sign in front of it. So I'm going to add it to each side. So I have the square root of 2x plus 1 equals the square root of x. So now that I have a single radical on each side, I'm going to square both sides since the index is an understood 2. And so now I have 2x plus 1, because remember the radical and the squared, they're going to cancel each other out. Same thing's going to happen on the other side. I'm going to be left with an x. I'm going to subtract that x over. Well, I guess I could have moved the 2x. I'm just going to keep going. So I get x plus 1 equals 0. And then I'm going to subtract the 1. And I get that x equals negative 1. So let's check it out. Y'all pray for me and my pencil lead, because I keep breaking it. All right, so I'm plugging in my numbers. Hopefully you are plugging in your numbers as well. And you might already notice something that looks a little bit off right here. When I've plugged in my negative 1, I have a square root of a negative 1. Well, what's the problem with that? The index is even. And because the index is even, am I allowed to have a negative value underneath the radical? Nope, because that's where your imaginary numbers would come in. And we are not looking to have imaginary numbers here. We just want to have real numbers. And so right away, that tells me that x equals negative 1 is not going to work for us. And so this is going to be a problem where we have no solution. So if you're plugging that in and your index is even, and you end up with a negative radicand, that just means the number underneath the radical is a negative, that is not going to work for us because we only want to deal with real values. Okay, last example, and then I will let you get started on the homework problems that are in your notes. So we have 2 radicals. They already have it where it's 1 on each side. So I'm going to start off the same way that I would with any normal problem. I'm going to square both sides, and I'm squaring it because it's a square root. Here's what I want you to pay attention to. If you look at the left-hand side, you'll notice that the -1 is not underneath the radical. Now over here, you see that +1 is. So the squared and the square root, they're going to cancel each other out, and they're going to leave us with 2x plus 1. But there's a problem on the left-hand side because the -1 is not underneath the radical. So what does this mean? Well, if I have this squared, that means that I have the square root of x minus 1 being multiplied by itself 2 times. And y'all may have guessed that this means we are going to FOIL. So let's FOIL this together. Start with first, square root of x times the square root of x. So remember, look what we have. We have a pair of x's, and our index is 2. So that means that I get just a plain old x. And if that's confusing, let me show you what that looks like. Square root of x times the square root of x simply means that I have those 2 x's underneath the same radical. I have a pair, it gets to come out, and there's nothing left underneath. That's why it's just an x. Hopefully that makes sense. Now let's do outer. So square root of x times -1 is negative square root of x. Inner, -1 times square root of x is also negative square root of x. And then last, -1 times -1 is positive 1. Now look at what happens. Those two middle terms, they are not going to cancel each other out because they're not opposites. So I still have some radicals. If I combine those together, so I still have the x out front, then I'm going to have -2 onto the square root of x. Remember, when you're adding and subtracting radicals, what's underneath the radical doesn't change, so the x doesn't change. What changes is your coefficient, how many of them you have. Add a -1 right here, and a -1 right here, and when you add those together, that's where that -2 comes from. And then I still have the +1 equals 2x plus 1. All right, we haven't seen a problem like this one yet in our examples, where we started off with radicals, and we raised both sides to an exponent, and we still have radicals. So we're kind of back to step 1, which is isolate the radical by itself. So I'm gonna subtract the x from each side and subtract the 1 from each side. So I get -2 onto the square root of x equals, over here what's going to happen? Well, I'm going to get x, and that's it, right? That cancels out. Okay, so if you want, you could divide both sides by -2 so that you would isolate the radical, and that would make sense. And you have a fraction, and a lot of y'all don't like fractions. So here's what I want to tell you. You can right here at this step, instead of continuing to get rid of that -2, because it's being multiplied, you can just go ahead and raise both sides to the second power. Because remember I told y'all earlier that that squared is going to go to everything in the parentheses because this is being multiplied together. So -2 squared is going to turn it into +4. The square root of x squared is going to turn into x. On the other side, we end up with x squared. All right, so good news. Radical is now finally gone. We have a quadratic because we have an x squared, which means we need to get 0 on one side. So I'm going to subtract this 4x on over. And I have 0 equals x squared minus 4x. All right, you might be wondering, what can we do? We can't do a sum and product chart because it's not a trinomial. We can't do difference of squares because there's an x with that 4. If it had just been x squared minus 4, we could have done a difference of squares, but it's not. However, we do have a GCF because these have an x in common. So I'm going to take it out. When I take it out, I'm taking it out using division. That's going to leave me with x minus 4. So I factored it using by taking out a GCF. And now I'm going to take each of those factors, set them equal to 0. Well, when I do that one to this first factor, I'm going to get 0. And when I do it to this second factor, I'm going to get that x is 4. So we have two possible solutions, but as always, let's go back and check it. I'm going to start with the 0 So going back again to the original problem, and everywhere I see an x, I'm going to plug in that 0. Okay, so the square root of 0 is 0. 0 minus 1 is negative 1. On the other side, 2 times 0 is 0. 0 plus 1 is 1. And the square root of 1 is 1. And we have a problem because negative 1 does not equal positive 1. And that means that x equals 0 is not a solution. So let's check the other one out. Again, go back to the original problem. And everywhere that you see an x, we are plugging in this time the number 4. All right, so square root of 4 is 2, and 2 minus 1 is 1. On the other side, 2 times 4 is 8, 8 plus 1 is 9, and the square root of 9 is 3. And guess what? That one doesn't work either. And so we have another problem whose answer is no solution. Neither one worked. All right, so obviously your homework here is to work on the 12 problems that you see at the bottom of your paper. And that's all I have in my head right now. I thought I had something else to say, but apparently not so much. So I hope you guys are doing well this week. Y'all let me know if you have questions. And that's it.